Hi, we're going to do a quick revision of AQA's Topic 1 GCSE Chemistry topic. The topic is atomic structure, so let's have a quick look at this. It starts off with um, early model of the atom. Now, before we get started, here's 7 questions that you can have a look. Let's see how you're getting on with these. You can pause the video and have a go at these 7 questions. Okay, let's have a look. How did you get on? So, number 1, what is the unit of resistance? Um, well, I hope you did a bit of physics there. So the unit of resistance is ohms, and that's the symbol for it. When a solid changes state into a gas, what is this called? So obviously this is topic 3. When solid, something like carbon dioxide, changes into gas, carbon dioxide, what is this is called? So we got sublimation. Number 3, what is the law of conservation of energy? That simply states that energy cannot be created nor destroyed. The only thing you can do is transfer it from one form, from one store to another store, energy store. Number 4, a cube has a sides at 2 centimetres long. Its mass is 48 grams. Calculate density. Well, if you think about it, density equals mass divided by volume. So the first thing you need to work out is volume. Now, because this is a cube, all the sides are going to be the same. So to work out the volume is 2 times 2 times 2, which is 8 centimetre cube. The mass is 48, so density equals 48 divided by 8, and that's 6 grams per centimetre cube. Okay, and that'll be worth 3 marks. Number 5, why are bulbs in a series circuit dim? That's because the voltage is being shared. Number 6, does a voltmeter go in parallel or in series? It always goes parallel to the component. And number 7, what are the colours and labels of the 3 cables inside a plug? So you've got the 3 cables, you've got brown, which is live, blue, which is neutral, and green and yellow, which is earth. Okay. Moving on to the actual topic then. So, it was Democritus that first came up with the idea, thousands of years ago, that everything was made up of tiny particles that cannot be split anymore, called atoms. And then early 1800s, John Dalton agreed with Democritus and confirmed the existence of atoms, and he described them as solid spheres. It was late 1800 where J.J. Thomson then discovered the electron, and he put forward his model of what an atom looks like, and he called it the plum pudding model. Now, the way to describe this for 2 marks, if they say describe the plum pudding model, all you need to say is it's a sea of positive charge with negative electrons inside, and that should get you the 2 models. It should get you the 2 marks. Moving on then, early 1900s, Rutherford carried out his scattering investigation, where he had a radioactive source that fired alpha particles, a beam of alpha particles, and he fired them at gold foil. And he got results he wasn't expecting. He got something different. And if the plum pudding model was correct, he expected the positively charged alpha particles to go straight through or be slightly deflected by the electrons. And by slightly deflection, we're probably talking about less than 4 degrees when it comes to angles. However, this is what happened. Most of the alpha particles went straight through because he said, well, most of the atom is empty space. Second thing, the nucleus must have a large positive charge, as some positively charged alpha particles were repelled and deflected by a big angle. Again, this was an angle of greater than 4 degrees. And then the third thing, the nucleus must be must be very small, as very few alpha particles were deflected back. And this led to the nuclear model. So this, Rutherford's investigation here, disproved this model, the plum pudding model. And from this led to the nuclear model of an atom. Here's some questions for you. You can pause the video here and have a go at these questions. Okay, let's see how you got on then. So these are recall questions. Here are the answers. You can self-assess. Okay, number 2. And number 3. There you go. Moving on, we then move on to the structure of the atom. And before we do that, we know what Rutherford did with his famous investigation. Rutherford also discovered the proton. It was Niels Bohr concluded that electrons orbit the nucleus in energy levels, which we call shells. James Chadwick later on discovered the neutron. And from that, this is now the nuclear model of an atom, where you have a central part called the nucleus that contains the protons and neutrons, and electrons orbit the nucleus. What you do need to know is the mass of each subatomic particle and the charge of each subatomic particle. As you can see, the mass of the electron is so small that it doesn't really make any difference to the mass of the atom. It is negligible. The mass of the atom is mainly concentrated around the nucleus. Here's 2 questions for you. Pause the video here. You can see each one. Number 1 is worth 4 marks and number 2 is worth 3 marks. So pause the video and have a go at these. Okay, so for number 1, to get you 4 marks, describe the nuclear model of an atom. So what you would say there is there is a nucleus at the centre of the atom. This nucleus contains protons and neutrons. The nucleus has a positive charge and it is surrounded by orbiting electrons, and these electrons orbit in energy levels or shells. Number 2 is an atom, a charged or neutral particle. Well, an atom is a neutral particle, and the reason for that is because the number of protons, which have a positive charge, equal the number of electrons, which has a negative charge. So the positive charges cancel out the negative charge, making an atom neutral. If we move on, when an electron receives energy, it moves to a higher energy level. Then when it falls back to the original energy level, energy is emitted. And that energy emitted could be in the form of light. We then move on to atomic mass and atomic number. Normally, the mass number is at the top and the atomic number is at the bottom, and you will find that the mass number is the big number, the atomic number is a small number. So, using a periodic table, you can work out the number of protons, neutrons, and electrons in each of these atoms. So, pause the video and have a go at this, please. Okay, let's have a look. So I won't go through all of them, but if we look at number 1, sodium. So sodium is atomic mass 23, atomic number 11. So it has 11 protons And we've already said an atom is a neutral particle, which means if it's got 11 protons, it has 11 electrons, and the number of neutrons is simply 23 take away 11, which equals 12. If we do number 5, hydrogen, this is hydrogen. Again, if we look at the number of protons, neutrons, electrons. Protons, it's got atomic number of 1, so the number of protons is 1, which means it will have 1 electron. And it has an atomic mass of 1, so to work out the number of neutrons is 1, take away 1, which is nothing. So hydrogen does not have a neutron. We'll do one more. We'll do phosphorus. So phosphorus has an atomic mass of 31, atomic number 15. So if we look at this, so atomic number is the number of protons, which is 15. And again, if it's got 15 protons, it will have 15 electrons. The atomic mass is number of protons plus number of neutrons inside the nucleus. So to work out number of neutrons, it's 31, take away 15, which is 16 neutrons. Okay. We'll then move on to isotopes. Now these are atoms of the same element with different number of neutrons or different atomic mass. And there's two examples here. So there's carbon 12 and carbon 14. Now what I would like to do is work out the number of protons, neutrons, electrons in each one. Pause the video here. Okay, if we have a look then. So just remind you, isotopes, atoms of the same element, but they have a different number of neutrons. So if we'll have a look at it, so this is carbon 12. And this is carbon 14. So if we look at number of protons, neutrons, electrons, protons, neutrons, electrons. Atomic number is 6, so it has 6 protons, which means 6 electrons. And atomic mass 12, so the number of neutrons is 12, take away 6, which is 6. If we move on to carbon 14, again, 6 protons, 6 electrons, but the number of neutrons this time is 14, take away 6, is 8. So this is what I mean by isotopes. Atoms the same element, but with different number of neutrons. That's got 6, and that's got 8. We'll move on then. Ions. An ion is where an atom either loses or gains electrons, and when that happens, it becomes a charged particle, and an ion is a charged particle. And something here, metals lose electrons to become positively charged ions. So sodium will lose 1 electron to become a sodium ion. So if you look at sodium, the electronic configuration for sodium is 281. It will lose 1 electron to become 28. So there's your sodium ion, it's lost 1 electron. Whereas if we look at magnesium, atomic number 12, so its electronic configuration is 282. In this case, this will lose 2 electrons to become 28, and it will be, because it's lost 2 electrons, it'll be 2 plus. And it's the opposite with non-metals. Non-metals gain electrons to become non-metals will gain electrons to become negatively charged ions. Moving on. Have a look at this. What ion will these numbers produce? Hint, you'll need a periodic table, in particular the group number. So fluorine, aluminium, oxygen, magnesium and potassium. Pause the video and have a go at these. Okay, if we move on. So fluorine is in group 7. It's a non-metal. It's got 7 electrons in the outer shell, so it wants to gain 1. And when it does, it becomes F minus. Aluminium is a metal. So metals lose electrons. It's in group 3. So it wants to lose 3 electrons. So the ion will be Al3 plus. Oxygen is a non-metal. So non-metals gain electrons. It's in group 6, which means it's got 6 electrons in the outer shell. It gains 2 more to make that magic number 8. So it will become O2 minus. Magnesium is a metal. Metals lose electrons. Its atomic number is 12, so it's 282. It will lose 2 electrons to become Mg2 plus. And potassium is in group 1, 2881, atomic number 19, so it will lose 1 electron to become K plus. Moving on. Here's some questions for you, so pause the video here. Have a go at these. Okay. I'll move on to application questions. Pause the video again. So, moving on. Here are the answers. Self-assess. And here are the recall. So, we'll move on. A few more retrieval practice questions. Number 1, what kind of ions do metals form when they react? So these are metals. Number 2, you can pause the video here. Have a go at these 9 questions. Okay, if we have a look, so number 1, what kind of ions do metals form when they react? Well, metals form positive ions. Number 2, what kind of ions do non-metals form when they react? Well, that's non-metals form negative ions. Number 3, are the majority of the elements of the periodic table metals or non-metals? Majority are metals, approximately 75%. 3 properties of both metals and 3 properties of non-metals. Metals, there's various answers here. Metals are conduct electricity, they're malleable, ductile, conduct heat, the strong, high melting point. Non-metals, brittle, soft, low density, insulators. So there's various answers there. Number 5, how are the elements arranged in the modern periodic table? Atomic number, you can see that. Number 6, what does the group number tell you? It tells you the number of electrons in the outer shell. Number 7, what does the periodic number tell you? It tells you the number of shells. Number 8, how many electrons do group 1 atoms have in the outer shell? If they're in group 1, it will be 1 electron. And how did Mendeleev overcome some of the early problems of the periodic table? Well, he overcome that by leaving gaps, because he said not all the elements had been discovered. If we then move on to group 1, so you can see some of the properties there: lithium, sodium, potassium, rubidium, sodium, as you go down the group. They're stored under oil. Soft metals you can quite easily be cut. They have a low density and they float on water. As you go down the group, the metals become more reactive, so reactivity is increasing. Sodium is more reactive than potassium, lithium, and so on. Don't forget, reactivity is determined by the atoms, its ability to either lose or gain electrons. If it requires not much energy to lose the outer electron for a metal, then that metal is a highly reactive metal. If you have a non-metal and it requires very little energy, or is quite easily attracts an electron, then it is something like fluorine, then it is a highly reactive non-metal. And that's a typical reaction of alkali metals with water. You can see that. And the gas produces hydrogen. For retrieval practice questions, have a look at these. Pause the video. Okay, so if we go on to this, number 1, what does the atomic number equal? It equals the number of protons, and it also equals the number of electrons. What is the charge of a proton? Is positive. What ion does barium atom form? Barium is found in group 2, so it's Ba2+. How many electrons do group 7 atom need during a chemical reaction? If it's in group 7, it wants one more to make that magic number of 8, so it'll be 1. Here's some of the reactions that you should be able to talk about and write the word or symbol equation. Pause the video here when you're ready. Then moving on, some word equations. I've done the first one for you, so you can pause the video and have a go at the next two. What you will find is the alkali formed is lithium hydroxide, in next one sodium hydroxide and potassium hydroxide, which are alkalis. Pause the video here, some more retrieval questions for you. Okay, so we move on. What is the middle block of the periodic table called? That'll be transition metals. How are transition metals different to alkali metals? Well, transitional metals have a high melting point, high boiling point, they have high density, and they are less reactive. What does group number tell us? Number of electrons in the outer shell. Number 4, name the gas, that should say, produced when an alkali metal reacts with water is hydrogen. Number 5, what type of solution is produced when an alkali metal reacts with water? It's alkali. What is the electronic configuration of lithium? So lithium has an atomic number of 3, so that will be 2.1. Number 7, list 2 properties of metals and 2 properties of non-metals. Metals can conduct electricity, metals can conduct heat, non-metals, low melting points, and are insulators. Number 8, name the only liquid metal found in the periodic table. That will be mercury. Sorry, not mercury, barium. Name the only liquid metal. Yeah, that would be mercury. Number 9, how can you separate a mixture of salt and water? That's distillation. And is H2O an element, a mixture, or a compound? It's a compound of hydrogen and oxygen. Moving on, group 7, so you can see that. Alkali metals we're reacting with group 7, such as chlorine. You get metal chlorides. There's 3 word equations for you today, so pause the video here and you can have a go. Okay, so what you should have got for the first one was lithium chloride, followed by sodium chloride, followed by potassium chloride. Alkali metals also react with oxygen. You can finish off the 2 word equations, pause the video. Okay, what you should have here is lithium oxide and sodium oxide and potassium oxide. We're now going to take a look at group 7, retrieval practice. Have a look at this. Number 1, why is group 1 alkali metals? Why is group 1 called alkali metals? Group 1 metal react with waters from an alkali solution. Number 2, why is sodium in group 1? It has 1 electron in the outer shell, and so on. And you can see the answers to number 3, 4, and 5. Moving on. Here's some questions for you today. Pause the video here and have a go at these. Okay, and a few more. Pause the video again. Okay. So if we look at these, number 1, Which group in the periodic table are alkali metals? That will be group 1. Number 2, do alkali metals have a low density or high density? Well, they float on water, so they're low density. Number 3, state the trend in reactivity. As you go down the group, reactivity increases. Number 4, alkali metals react with non-metals. What type of bond do alkali metals form during this? So a bond between a metal and a non-metal is ionic bond. Give 2 properties of compounds that are produced during these reactions. Well, ionic bonded compounds are soluble in water and they have high melting points. Number 5, write down the general word equation for a reaction of an alkali metal with water. So you're going to have alkali metal with water. You'll get metal hydroxide plus hydrogen. And B, will the solution formed be, it'll be alkaline. Number 6, write a general equation for the reaction between alkali metal and chlorine gas. You will get alkali metal plus chlorine gas will give you there. Alkali metal plus chlorine will give you metal chloride. Number 7, name the compound that forms when potassium reacts with oxygen. That's potassium oxide. Number 1, more reactive, sodium or potassium, it's potassium. As you go down the group, reactivity increases, you say, so potassium is below sodium. Lithium or rubidium, it would be rubidium. Number 2, the boiling points of group 1 metals decrease as you go down the group state, which has a higher melting point. Well, if the boiling point decreases, lithium will have a higher melting point, and potassium for B. And is potassium oxide a covalent or ionic? Well, potassium is a metal, oxygen is a non-metal, so the bonding between a metal and non-metal is ionic. We'll move on. We're now going to take a look at group 7. You can see that. Fluorine, chlorine, bromine, iodine. In this case, the melting point is increasing and the reactivity is decreasing. Displacement reactions. Here's a few questions for you that you can have a look at, and the answers are already included. Pause the video here. Okay. Now look at this one. Chlorine plus potassium bromide produces potassium chloride and bromine. Now the rule is the more reactive chlorine has displaced the bromine from potassium bromide. So there's 3 here for you to do. Pause the video, you can have a go. Okay, if we move on. We have fluorine with sodium iodide. Fluorine is more reactive, so it will displace the iodine to give you sodium fluoride plus iodine. Bromine with lithium iodide. Bromine is more reactive than iodine, so bromine would displace the iodine to give you lithium bromide plus iodine. And the next one, potassium chloride plus bromine. Bromine is less reactive than chlorine, so it is unable to displace chlorine, so there'll be no reaction there. Then reaction with non-metals. So hydrogen plus chlorine gives you hydrogen chloride, hydrogen plus oxygen gives you hydrogen oxide. These are covalently bonded substances. Reaction with metals. Moving on. Here's some questions for you to have a go. You can pause the video. And then a few more, pause the video here. Okay, so if we look at these, how many atoms are in a molecule of halogen? Halogens are diatomic, so there'll be 2 atoms. Where are the most reactive halogens found? At the top or the bottom? Well, if reactivity decreases as you go down the group, so the most reactive ones will be found at the top. Explain the trend. I've just said that as the reactivity as you go down the group 7, reactivity decreases, and the melting point as you go down the group, melting point increases. Which is more reactive, chlorine or iodine? A is chlorine, B fluorine, high boiling point. A is iodine, B is bromine. And number 3, would a displacement reaction occur? A, chlorine, yes, because chlorine is more reactive than bromine. B, no, bromine is less reactive than chlorine. C, iodine and chlorine, the answer is no. And D, chlorine and calcium oxide, the answer is yes, chlorine is more reactive than iodine. And that's the lesson for today. Hope you found that useful.